Everyone, in this video we're going to talk about how we can solve some radical equations. So what makes an equation radical? So equations with radicals that have variables in their radicands are considered radical equations. So if we just see an equation where we have the square root of 6 or the square root of 9 or something like that, that technically is not a radical equation. For our equation to be a radical equation, we need to have the square root of something with an x, some kind of variable under our radical, because under the radical that is the radicand. And that's what it's saying here. We have to have a variable in the radicand. So how do we solve these radical equations? Number one, we want to isolate the radical on one side of the equation. So once we get just the square root of x, or whatever we're working with on one side, no addition or subtraction or multiplication happening, then we're going to raise each side of the equation to the same exponent to eliminate the radical, and then we're going to obtain a linear or a quadratic or some other polynomial equation. And so then from there we can just solve that equation, whether it be a linear equation where we just have a simple or a multi-step equation, or if we have a quadratic equation we have to factor it and find the zeros. That's what we need to do. So we're going to look at 4 kinds of examples in this video. We're going to look at just some standard examples, like the easiest examples we could see, some examples where we have an extraneous solution or a solution that is an apparent solution, but once we plug it back in it actually doesn't satisfy the original equation. And then an equation where we have 2 radicals, maybe one on each side. And then a couple equations where we have rational exponents or fractions as exponents. So let's jump right in for our first example here. So we have 2 times the square root of x plus 2 divided by 8. So we want to undo this multiply by 2, so we're going to divide both sides by 2. So now we have the square root of x plus 2 is equal to 4. Now we can go ahead and raise both sides. Since we're taking the square root, we want to square both sides. So that's going to give us x plus 2 is equal to 16. We subtract the 2, and we get x is equal to 14. Okay? So now, we're going to go ahead and circle this, but we are going to check our work because we could have an extraneous solution popping up. So let's go ahead and plug 14 in right here for x. So this would be 2 times the square root of 14 plus 2 is equal to 8. So 2 times the square root of 16. Square root of 16 we know to be 4, so this is 2 times 4, so we get 8 is equal to 8. So that one checks out. We know our solution is 14, okay? All right, number 2, we have the cube root of 2x minus 5 minus 2 equals 3. So we want to go ahead and add this 2 to both sides so we can undo that. Now we have the cube root of 2x minus 5 is equal to 5. So now undo the cube root, we're going to cube both sides. So now we get 2x minus 5 is equal to 125. Now we can add 5 to both sides. So we get 2x is equal to 130. And now we divide by 2, and we get x is equal to 65. Okay? So once again, let's plug in 65 to our original equation to make sure we get the right answer. So cube root of 2 times 65 minus 5 minus 2 is equal to 3. So we know the cube root of, well, 2 times 65 would be 130. 130 minus 5 would be 125. And we just figured out that 5 cubed was 125, so the cube root of 125 would be 5. 5 minus 2 equals 3, and we know that is good. So our solution is 65. All right, number 3, we have the square root of 2x plus 7 is equal to x minus 4. So there's no operations that we need to undo here because we already have this radical by itself. So I'm going to go ahead and square both sides. So on the left, we just get 2x plus 7, but look what happens on the right. Now we have a difference, or the square of a binomial, right? The square of a binomial, we have x minus 4. So if we remember the square of a binomial pattern, we can FOIL this pretty easily. It's just going to be x squared minus 8x plus 16. So now we have a quadratic, right? And anytime we're trying to solve a quadratic, we want to set one of the sides equal to 0. So let's move this 2x and 7 over here. So minus 2x minus 7. So that's gone, that's gone. Now we have 0 equals x squared minus 10x plus 9. So now we want to factor the expression that we have on the right side. So we want to think, okay, what 2 numbers add to negative 10 but multiply to 9? So that's going to be x minus 9. I guess we can add our 0 equals in there. So let's say 0 equals x minus 9 times x minus 1, right? So negative 9 plus negative 1 would be negative 10. Negative 9 times negative 1 would be positive 9. So now we use the zero product property to say that x is equal to 9 and x is equal to 1. Okay, now let's plug these back in just to make sure one of these solutions is not extraneous. So let's go back to our original equation. So we have the square root of 2 times 9 plus 7 equals x, not x, because we're plugging in 9 minus 4. So 2 times 9 would be 18, 18 plus 7 would be 25. So this is going to be the square root of 25, and this is equal to 5, so we know we're good. So 9 is a good solution. Now let's check 1. So now we're going to do 2 times 1 plus 7, square root of that, equals 1 minus 4. So 2 times 1 would be 2, 2 plus 7 would be 9, square root of 9 equals negative 3. Now, when we say this, let's imagine that we just had an x under the square root, so the square root of x. So let's say it looked like this. Well, we know that the square root of any number can't be negative, right? There's only one real solution. And so in this case, we're going to say that does not equal, and this would be our extraneous solution. So extraneous. So 9 would be our only actual solution to this equation, okay? All right, next 3 examples. So now number 4, we got a radical on both sides, okay? So we think, okay, let's subtract this 1, but really it's not gonna help us because then we just have a minus 1 on the other side. So let's just go ahead and square both sides of our equation. Now on the left here, we have essentially the square of a binomial again. Imagine, square of a binomial, sometimes we think of it as like a plus b squared. So our pattern is a squared plus 2ab plus b squared. So if we think of the square root of x plus 6 as a and 1 as b, then we could factor it, or we could FOIL it out like this. We could say a squared, so x plus 6, plus 2ab, so 2 times the square root of x plus 6, and then b squared, so that would just be 1. And then the other side is just 7 minus x. Okay, so now we can combine some like terms. So I notice I have a 6 here and a 1, so this would be x plus 2 root x plus 6 plus 7 equals 7 minus x. Now I notice I have a positive 7 on both sides of my equation, so those will cancel, and then let's add this x over here. So now we have 2x plus 2 times the square root of x plus 6 is equal to 0. Okay, so now we can move our negative 2x, right, which we probably could have just subtracted x in the previous step. So now we have 2 times the square root of x plus 6 is equal to negative 2x. Now let's divide both sides by 2. So now we have the square root of x plus 6 is equal to negative x. Now we have a radical on one side, we've isolated it, so let's go ahead and square both sides of this. So now we have x plus 6 is equal to, and negative x times negative x would just be x squared. So now let's move our x and our 6 over here so that now we can have a quadratic equal to 0. So now we can use the zero product property and we can factor this. So now what adds to negative 1 and multiplies to negative 6? We can say 0 is equal to, and that would be x minus 3 times x plus 2. So that would give us x is equal to 3 and x is equal to negative 2. Okay, now let's check those. So I'm going to kind of write over in this area, but we will erase it once we get to number 5. Let's plug these back in and make sure that they work. So for 3, we would have 3 plus 6, we're taking the square root of that, plus 1 is equal to the square root of 7 minus 3. So this is going to be the square root of 9 plus 1 equals square root of 4. So the square root of 9 would be 3, 3 plus 1 would be 4, but the square root of 4 is 2. So that actually does not work for the original equation. So x equals 3 would be out. Okay, so now let's think about negative 2. So now we have negative 2 plus 6, we're taking the square root of that, plus 1 is equal to 7 minus negative 2, so 7 plus 2. So negative 2 plus 6 is going to give us a 4, so this would be the square root of 4, plus 1 is equal to 7 plus 2 would be 9. So the square root of 4 is 2, 2 plus 1, square root of 9 is 3, and that one checks out. So our only answer here would be x equals negative 2. Okay? All right, let me take these away so that we can get into, actually, you know what? I will just move this over here in case we're still looking at that. And then after we get done with number 5, I will delete that. Okay, now if we notice on 5 and 6, they look a little bit different. We have rational exponents now. So we're still going to raise both sides of the equation to an exponent, but essentially we're trying to neutralize or eliminate that exponent. So if I have 3/4 and I raise it to another exponent, we're going to be multiplying those two exponents together. So we want to raise to the reciprocal so that when we multiply them together, our exponent becomes 1, which essentially means it goes away. So here, I'm going to go ahead and add 2 to both sides. And so now I have 3x to the 3/4 is equal to 27. So now I'm going to raise both sides of this. I'm going to move this equals 27 over just a bit to the 4/3 power, 4/3. So now what that's going to do is basically eliminate those two exponents. So now on the left I just have 3x, and now on the right I could think about this as, okay, this would be 27 to the 1/3 raised to the 4th power, right? That's kind of a rational exponent rule we could do there. So now this is going to be 3x is equal to, this would be the cube root of 27 to the 4th power. Cube root of 27 would be 3, and 3 to the 4th power is 81. So now we can divide both sides by 3 to get x is equal to 27. Okay, so now we can plug this back in to check. So we would do 3 times 27, and we're going to raise that to the 3/4 power minus 2, and that should equal 25. So 3 times 27, we know that's 81. So 81 to the 3/4 minus 2 equals 25. Well, 81 to the 3/4, that would be like 81 to the 1/4 and then cubed. So the 4th root of 81, and that's going to be a 3, and 3 cubed would be 27. So that checks out. Our solution is 27. All right, so let's take away this part we did, checking our work for number 4, and let's handle number 6. Okay, so we can go ahead and raise both sides here to an exponent of a 2, because the reciprocal of 1/2 would be 2. And that's going to get rid of our 1/2 exponent on the left side. So now we have x plus 12 is equal to x squared. So let's go ahead and subtract x and 12 so that we can have all of our terms on the right side, and we can set this quadratic equation equal to 0. So now we want to factor this. What adds to -1 and multiplies to -12? Well, that's going to give us x minus 4 and x plus 3. So zero product property tells me x is equal to 4 and x is equal to -3. Now, once again, let's check those to make sure we don't have anything weird happening here. So we would have 4 plus 12 to the 1/2 is equal to 4. So this would be 16 to the 1/2, which would be the square root of 16, and that's equal to 4. So that checks out, that's good. So x equals 4, that's a good solution. Now we would have -3 plus 12 to the 1/2 equals -3. Now this would be 9 to the 1/2, which would be the square root of 9. But like we talked about a minute ago, if this were the square root of x, like what number do we take the square root of to get a negative number, right? That can't happen. It's not a real solution. And so in this case, we're going to say that actually is an extraneous solution. And so our only real solution here would be x is equal to 4. And that is how you can solve various types of radical equations.